Populations and Resources Unit, Lesson 1.4, Births and Deaths in the Jelly Population. Activity 3, Modeling the Moon Jelly Population. Births and Deaths in the Moon Jelly Population. To make their thinking clear, scientists often use models to show their ideas about how something works. In this unit, you will be using a visual model, called a modeling tool, to show your ideas about why populations change size in an ecosystem. The top circle represents the jelly population when it was stable, and the bottom circle represents the jelly population when it was increasing. Each box represents an individual organism, moon jelly, in the population. This model initially shows just 6 moon jellies in the population. Of course, there are many, many more moon jellies, but in this simplified model, you will use small numbers to show basic ideas about how the population changes in size. The key shows that a box represents an organism in a population, a crossed out box represents a death, and a new box with a B represents a birth. I need to figure out how many births and deaths to show for the stable population. As the key explains, to show a birth, I draw a box with a B. To show a death, I cross out a box that is already there. There are many moon jellies in this population right now. If I wanted to show the same number of births as deaths, I could add 2 boxes with B and cross out 2 boxes. If I wanted to show more deaths than births, I could cross out 1 more. If I wanted to show more births than deaths, I could add 1 more box with a B. It is not important exactly how many births and deaths we draw, but it is important to show how the number of births compares with the number of deaths when the population is stable or changing. Students, you can refer to this graph or the graph on your device as you work. You have a Google Slides modeling tool in Classroom to do this activity if you choose. What could have caused the size of the moon jelly population to increase? When the moon jelly population was stable, the number of births had to equal the number of deaths. It does not matter how many births or deaths are represented, just as long as they're equal. When the jelly population was increasing, there had to be more births than deaths. How did you model this? There are 2 possible scenarios. The population increase could be due to more births or fewer deaths. The sim and the token activities you did showed us that for a population to increase, there have to be more births than deaths. This can happen because there is an increase in the number of births in the population, because there's a decrease in the number of deaths, or both. We will need to learn more about what can cause births to increase or deaths to decrease, and gather evidence about which of these things might have been happening in the jelly population. Claim 1 says that the births increased after the year 2000. The diagram shows that the population is larger after 2000 because there are more births. It shows 2 births before 2000 and 3 births after, while the number of deaths stayed the same. Claim 2 says that the deaths increase after the year 2000. The diagram shows that the moon jelly population is larger because there are fewer deaths. It shows 2 deaths before 2000 and 1 death after, while the number of births stayed the same. You will continue to gather evidence to determine whether moon jelly population increase was caused by more births or fewer deaths since the year 2000. End of activity.